Hey everyone, take a look at pages 54 and 55 here in the notes. So we're going to start here in the first section, page 54, example 55. Now it does say you try it, but as I mentioned previously, we're going to take a look at a couple of these, and then I'm going to have you kind of like pause the video for a minute or two, kind of work on it yourself on the other ones, see if you can kind of get the right answer, and I'll kind of show you how it's kind of supposed to be worked out. So the one specifically we're taking a look at is going to be this whole section here, bottom of the page, example 56. This one's a little bit different. It's a little bit of solving with combining logs. And then we're going to take a look at some of these ones that we have seen before. That's why it says flashback. So we're going to take a look at probably like half of those and see if you can do the other half. All right, so we pull up here on example 55. So for parts A, B, C, and D, we're given a logarithm, and we're asked to try to solve for x algebraically. So we're going to have to try to rewrite this as an exponential at some point and kind of see what we're left with. Now, as I mentioned before, these problems are a little special because we noticed that part A is something we kind of seen before. So we're going to do that first to kind of get a little bit of like a refresher how we go through solving a log. But for parts B, C, and D, we have some more interesting insides there. We notice that instead of just having an x, there's a x squared. So that's going to kind of change how we, one, solve, and then two, what we do with our answers. Okay? So we're going to take a look at part A first. So we're going to try to solve this log base 5 of x plus 30 that equals 2. Okay, so we're going to pop over here. Just go ahead and write that down. So we got a log base 5 of x, and it's plus 30 equals 2. Now, typically when we're solving logs, we want the log by itself. So we don't want nothing adding, subtracting, multiplying, or dividing our logarithm, which here, there's nothing on the outside. Now we do see a plus 30 that's inside the log. That's okay. We just don't want stuff on the outside of the log, so we don't want anything like multiplying in front here or dividing it, or see some plus minuses on the outside. So what's going to happen for us is, since this is already kind of set up correctly, we can go ahead and just do our rewrite step first. So we notice the base of the log is 5. It is equal to 2, so when we rewrite this, it becomes 5 squared equals our inside x plus 30. Now, we can take 5 squared. We know that's a number. That's going to be 25. It's going to equal x plus 30. So the only way this works is if we subtract 30. It'll leave us with an answer of negative 5. Okay, so it's a pretty basic one. We just had to rewrite first, and then pretty much just square that 5 and then subtract 30. This is our result. Now, things we haven't really been doing that much have been, we haven't really been taking these values and checking what's called extraneous solutions. What that really means is that since we have a logarithm, we talked about how we have certain numbers where we're undefined. So essentially, we don't want to have 0 or anything less than it inside of our logarithm. So we got to make sure we can plug this negative 5 back in and we don't get some weird answer inside. So if I take negative 5 add 30, we get 25. And since it's a positive 25 inside the log, we're okay with this answer. This is something we're going to have to do for the next part. And it's usually with the quadratic equations, we usually have some issues. So for right now, pretty typical. But for B, things get a little bit more interesting. So first off, we're doing log base 6. So I have a log base 6 of x squared plus 7x. And it gets plus 12. And it equals 1. So just like part A, the log's already by itself. We don't have to do anything too specific here besides just the typical rewriting step. So it's going to start off the same way like part A. Well, we're going to rewrite it. So it's going to be base of 6 to the power of 1 equals, in this case, x squared plus 7x plus 12. What's different now is instead of having like x plus 30 like we did for part A, we have this whole quadratic equation. So what's going to happen here is really this turns into a 6. So we don't really have to keep the 1 here. So that can just technically go away. So we're left with just 6 equals x squared plus 7x plus 12. And then we kind of have to try to solve this quadratic. Now, pretty much the only thing we know what to do is factor for quadratics at this point. So in order to really factor, we want this equal to 0. So that's going to be the first thing we need to do. So right now it equals 6. So we're going to move the 6 over and kind of group it with the 12 by minusing it over. And so you get x squared plus 7x. 12 minus 6 is a positive 6. And our whole equation equals 0. What that allows us to do now is we can actually take this equation and factor it. So if we can factor this, will give us 2 different terms we can then solve for. So we need 2 numbers to multiply to 6, add to 7. That's going to be 6 and 1. So we just get x plus 6 and x plus 1. And then our shortcut here, it's just the opposite of what's in there. So our solutions are negative 6 and negative 1. Now we do have a slight issue here. There is a possibility where some of these answers might not work. So what we should do is go ahead and plug these numbers back in to make sure we don't get any funny business. Okay, so for example, if I take negative 6 and plug it back in, so I'm going to say we're going to test x equals negative 6. If I plug this back in, we get negative 6 quantity squared plus 7 times 6, or negative 6, excuse me, plus 12. So I'm kind of just plugging it into the inside, and what we want to make sure is that this answer is not 0 or anything less than 0. Because our answers, or I should say, what we plug into a log should always be greater than 0. Now this turns into 36 minus 7 times 6 is going to be, what can I think, 42. And then you get plus 12. So as long as this equals a number bigger than 0, we're going to be happy. So if we do this, 36 plus 12 would be 48. So this is just equal to 6. This is positive, so this checks out. So this is a valid solution. If we plug in negative 1, we should test that as well. We do the same thing. Negative 1 squared plus 7 times negative 1 plus 12. So if we test this out, we get 1 minus 7 plus 12. This will give us 6 as well. That seems to check out. So in this case, we don't have any extraneous solutions. We just have 2 solutions. So we have 2 answers. Okay? And this is what we should expect to see when we're doing quadratics. We're going to have 2 answers, but we have to be a little careful. We have to test them to make sure they're not extraneous, or what I like to call fake answers, right? So the idea here is, since we have different possibilities, we have to test them to make sure that they work correctly. And that's because our logarithms are a little bit particular with their domain, right? We have limitations of what we can plug in, so we need to make sure that these are falling within those limitations. So we check that by just plugging it in and making sure our answer is not negative or 0. So this works out pretty nice, so both answers work. Let's try part C. So let's go ahead and scroll this down. Doesn't want to do that. We'll do it like this. There we go. So for part C, we're dealing with this equation, log base 2 of x squared minus 7x equals 3. So let's try this one. So log base 2 of x squared minus 7x, and it equals 3. So same thing. Logs by itself would rewrite it. So you get 2 to the third equals x squared minus 7x. Now 2 to the third, you're going to do 2 times 2 times 2, so which means you're going to get 8 equals this x squared minus 7x. If we minus this over, it will set up our quadratic equation of x squared minus 7x, then minus 8 equal to 0. So we got to factor this. So two numbers that multiply to negative 8 add to negative 7 would be negative 8 at 1. So if we set this up, we get these two factors of minus 8 and plus 1, which means our possible solutions are 8 positive, 1 that's negative. And again, it's always the opposite sign. Now, just like part B, these solutions may not work, so we have to test it. So let's test 8. So if we do our test for x equals 8, we're going to plug 8 in and see what happens. So it becomes 8 squared minus 7 times 8. Well, this is 64 minus 56. So our answer is just 8. So that checks out. It's positive, so we're good. What happens if we test negative 1? So if I plug in negative 1, are we going to be good? So we do negative 1 squared minus 7 times negative 1. So you're going to get 1 plus 7, which gives us 8. Also checks out. So it looks like part C is also good for both solutions. Okay, and again, what we're testing to see is, do we have a negative answer for these? Okay, so if I plug it into the log, are we getting a negative answer, or are we getting 0? Now, what I want you to do real quick, see if you can do part D on your own. So go ahead, pause the video, try to see if you can figure it out. I'll give you a hint. The log's already by itself, so you're going to be doing the same exact first step as the previous 3, which is rewriting. So go ahead and try to rewrite it first, see what you get, move that number over, and see how it factors. Alright, at this point, maybe you unpause the video, and you're going to see, did I get the right answer? So let's work it out. So for part D, we're going to move this over just a hair. Just a little bit. Cool. So for part D, it's a log of base, was it 3? Inside's x squared plus 10x plus 24. And it equals 1. So as you're solving this out, what I'm going to do is I'm going to kind of skip a step here. We should get is x squared plus 10x plus 24 equals 3. And when you minus it across, you should have got x squared plus 10x plus 21 equal to 0. Okay, so we should have. Now your factors are plus 7 and plus 3. So if you factor, this is what your factors should look like. So it's 7 plus 3 is 10, 7 times 3 is 21. And then the possible solutions are negative 7 and negative 3. So we need to go ahead and test these and make sure, do we get any weird, funny business going on here. So let's do our test. Or tests in this case, we got to do 2. What happens to do negative 7? Well, we're going to get 49 minus 70 plus 24. So if I square negative 7, you get this number, 49. Multiply here, and then you add the 24. Now, if I add these up, okay, 49 plus 24. That's going to give you, what, 73? So you should get an answer of 3 here. So it looks like this checks out. If we test our other one, so we test -3, you're going to get 9 minus 30 plus 24. This is also going to give you 3, which checks out. So again, both these solutions work. Stop doing that, please. Okay. So both these solutions are sufficient. Okay, so both these are going to work. So for all these cases, we didn't run into an issue where we kind of have a undefined situation, but you should always check to make sure, because there is always a possibility you can get an answer that may not really fit that mold. Okay, it has to be something you're kind of cautious about, especially with quadratics. Now we do have a challenge problem. So the next example is a little bit of a challenge problem. And what we're doing for example 56 is we're trying to combine the concept of condensing logs with solving. So you notice here in this case that we have 2 logs being added together. We notice they both have a base of 3, and that should kind of make you think about a specific property we talked about, which is condensing. So what we're going to be doing here is we're going to actually condense these first, see what happens on the inside, and then kind of do what we did for the previous problems. So let's take a look. Example 56. Oops, help if I had the pen. All right, example 56. So doing a log base 3 of, first one's x plus 6. And we're adding another log of the same base, which is pretty important. We can only condense if they have same bases. In this case, it's x plus 4. And it equals 1. So what's going to happen is we can't really do any rewriting just quite yet. And that's because we have more than one log, which is something you don't really want. But we can change that. We can say this is really log base 3 of, and we just can multiply this together, x plus 6 times x plus 4. So if I was to multiply that out, you're going to get x squared plus 10x plus 24. So if you FOIL this out, this is what you should get as your answer. Okay, this kind of looks familiar, right? So we take a look back at here again. It's pretty much this problem. So we notice here, if we look back, right, when we condense them, we multiply them together. So we got x plus 6 times x plus 4. So it gives you this x squared plus 10x plus 24 if you FOIL it out, or do your box method, last method, whatever you prefer. And essentially just brings us back to this problem. So we get the same answer. So the only difference between this example and part D is the fact that we condensed first. Besides that, it's pretty much the same. So you would proceed by doing our steps here, where we rewrite it as 3 to the power of 1, and then minus it over, factor, and we kind of get the same type of solution. So let's go ahead and take a look at that. So we know from previous experience that this is going to give us essentially x equals -7. And what was the other one again? Let's see. It was -7 and -3. Now there is a slight difference though. Is what happens if we test these answers now? Well, we have to test twice for each number. So if I test -7, okay, I got to make sure if I plug it in here, we're good. I got to make sure I plug it in here, we're good. But here's the issue, right? -7 plus 6 is -1, and also -7 plus 4 is negative 3, right? Both these answers are negative, so this is bad. So this is a bad solution. So let's go ahead, we'll change it to, we'll do magenta, that'd be kind of cool. So negative 7 is actually not a solution. It worked for the previous example, right? So we looked at, part D in example 55. It worked because when I plugged negative 7 in there, they weren't separated. So it still worked. But here, if I plug in negative 7, we are having issues in both logs, right? We have a negative here and a negative here, so it's double bad. So we got to exclude it. However, if we test negative 3, everything works great because negative 3 plus 6, that's 3, that works. Negative 3 plus 4 is 1, that works. However, these two do not work. So what happens is for testing negative 7 it fails, but for testing negative 3 it passes. So here's a case where we actually run into that problem where one of them works and the other does not. Okay, and when we really write our answer, you can just pretty much go and just say it's just x equals negative 3 only. Okay, and that's good. You can cross it out on your paper and just show the answer that way, or you can just write it by itself. Both work. As long as you're showing your work, I'm going to see you pretty much eliminated that result to give you negative 3. So for example 55, when we're testing out those values, this is what we're looking for. We're trying to we're trying to verify, I should say, that our solutions work. They don't cause any issues with our logs giving us zeros or negatives inside when we plug it in. Okay, so this is mainly the new stuff that we haven't really dealt with, right? We solved logs before, but like part A, we kind of did that before. We're used to that. But what happens when we have x squareds in it? I mean, the only thing different is you have to factor, okay? And just be careful when you're factoring, okay? You make sure when you rewrite it, you move that piece back over, right? So like for part B, it became 6, we minused it over, combined it all together, right? For part C, we had 2 to the third, because it was base 2 equals 3, so it becomes 2 to the third. We minus that 8 back over, then we factored. Okay, part D, same thing. We had 3, we moved it over. Okay, same thing for example 56. When you rewrite it, you get 3 to the power 1, we move it over. Okay, so you always want to make sure you move that piece back over before you factor. Now, we already went over example 58 in class, so we did the bottom of this one. So real quick, we're just going to kind of make sure we're kind of cool with these problems. If you want to take a kind of pause here and try them by yourself first, that would probably be a good idea, because you should already know how to do these at this point. These ones are things we saw in the quiz number 3 already, so this isn't like our first rodeo for sure. So if you want to try these out first, I would recommend doing so. So if you want to pause real quick, knock them out real quick. I'll give you like some time to do that. So I'll give you about like 5 seconds to kind of pause and work on that, and then we'll take a look kind of what these answers should look like. Alright, so hopefully at this point you tried at least some of them, if not all of them. Hopefully all of them, that'd be nice. So what we're going to do is we're going to kind of take a look and see that A, B, C, and D are all exponentials. Okay, so we're going to talk about how we solve them, and then we have these two logs separate. Pretty much for all of these, the log or exponential is not by itself, so it's going to require us to rewrite. Okay, so if we're doing like part A, okay, first step, we see it's 10 times this exponential, so we're going to go ahead and just probably divide that 10 out first. So what happens is we will get something like this. Okay, and I'm not going to give it like every step. I'm going to kind of show you the main important details. You're going to be left with this. 10 to the 3x equals 10. If I rewrite it, it becomes log of 10 equals 3x, and a log base 10 of 10 is always equal to 1. Now you could technically type in the calculator. You don't have to. That's a property we talked about before. But in this case, we just get 1/3. So that's a pretty nice one. Not too shabby. So we divided by 10 first. So once we did 100 divided by 10, we got 10, and kind of worked out from there. B, similar, but now we're not multiplying 10 in, we're adding it in. So the first step is going to subtract by 10. So you get something that looks like this. So you get 10 to the 3x equals 90. Okay, very similar situation. We're going to rewrite, but this time we get log of 90 equals 3x. Now here's the thing. Log of 90 is going to be some crazy decimal. So what I'm going to suggest, so you don't get any rounding errors, we'll divide first and just type in the calculator the whole expression of log of 90 over 3. As long as you do this, it'll work out pretty good. So if you take out your handy dandy calculator, log of 90 turns into like 1.95 something. So if you divide it by 3, our result is going to be x equals 0.65, and that's rounded to 2 decimals, and that's what they want. So you should get 0.65. This is A, this is B. Okay, for C, now we have base E. So first step, it's 3 plus, so we're going to minus it. So what's going to happen is you're going to get E to the 4x equals 14. So we minus it, 17 minus 3 is 14. And then we just rewrite. Now here's the deal. For A and B, they're base 10, so I didn't really write the 10 here. For E, our base is E itself, which means we have to use ln. So you get 4x equals the natural log of 14. And as we divide by 4, this will tell us what x equals. Again, ln of 14 is going to be some number with some crazy decimal on it. So I'm going to go ahead and type in my calculator natural log of 14 divided by 4. And you're going to get almost a similar answer, 0.66, if you round to 2 decimals. So those are the answers you should have got for the first 3. Now if you're paying attention, D and C are the same, so we're going to skip it. Okay, more likely it was supposed to be like 3 times, but it's not. If it was 3 times, then you would just divide. Now for E, it's 6 times our log, so we're going to go ahead and divide by 6 first. So what's going to happen here is you're going to get a kind of a fraction of 4/3. So we get log of x plus 2. So this is part E. So we get log of x plus 2. We divide by 6. We get a fraction of 4/3. Okay. So divide by 6, we get 4/3. And then if we rewrite this, you just get x plus 2 equals our base, which is 10, right? There's no number here. It's always base 10. And then the equals becomes the power. So this point, x is really just this 10 to the 4/3 minus 2. So if I take 10 raised to the 4/3, and I subtract 2 from that answer, you should get 19.54 if we round to 2 decimals. So that'll be our answer for E. And then the last one, part F here, last one we're doing, it's 4 plus 6 times our log. So there's 2 things on the outside. We haven't seen this too much. So let's write out the whole thing. So it's going to be 4 plus 6 times our log. In this case, the base is 10. It's x plus 2 inside, and it equals 8. So it's kind of similar to our previous question. So here's the deal. We got two things. We see there's a 4 and a 6. The 4 is adding, the 6 is multiplying. So first step is we're going to subtract 4. So we get 6 times our log of x plus 2 equals now 4. We divide by 6. We're going to get 2/3 here. And so when we do this answer, you're going to get x equals essentially 10 to the 2/3 minus 2. So I kind of did two steps there. I did the rewrite as 10 to this power, and just like here, we minus 2. So we minus 2 here. So in this case, if we do this, our answer turns into 2.64. And that'll be our answer there. So out of these, says 6, but technically 5 different problems here. You know, the first 5 aren't too bad. So, you know, doing parts A, B, C, you're solving exponentials, so you're trying to make sure they're by themselves. All these cases we're not. We divided by 10 first, right? So go back to A, we divide by 10, then we rewrite. For B, we minus 10, then we rewrite. For C, we minus 3, then we rewrite. For E, we divide by 6, and then we rewrite, but here we start with a log, so when we rewrite, we're using exponentials. And same thing for part F. We had to do two things first. We have minus 4, then divided by 6. Okay? So out of these, this one's a little bit trickier just because you had those two steps. Okay? But this is more typical, right? So we were used to kind of doing these. You know, the main new thing, like we mentioned, is on that page 54, where what happens if we're dealing with these powers of 2, okay? And the only real difference between, like, you know, B, C, D here, for example, 54, example 55, is the fact that you have powers of 2. So you just got the factor. I mean, that's really the major difference, okay? All right. Hopefully here in the flashback section, you're able to kind of, you know, get them pretty much right and kind of, you know, see where you might have some issues. If you're still kind of a little confused on it, we can probably spend some time on Monday to kind of go over a couple of details here, if need be. Or you can email me. I can kind of, you know, do that too. You can kind of show me what you got, and, you know, I can see kind of where things might be going off the rails. Okay? Well, hopefully you're enjoying your Saturday here, or if you're watching this early, maybe Friday. But hopefully you're, you know, this isn't too bad for you. I know some people kind of get a little intimidated here with the powers of 2, but essentially the main thing is you're factoring, and you just want to make sure you test your solutions, okay? So it's a good habit. Plus, it's going to tell you in the instructions. It kind of tells you check your answers, okay? Keep in mind the domain of the log function. That's just saying, hey, by the way, you can't have 0 or less. So as long as you're plugging your answers back in and checking them, doing that test that I showed you, it's usually not too bad.